Okay, so now we're going to talk about the traditional view of computation and computability. Um, so we'll just start off with this. This right here is actually a picture of a bunch of women from the early 1900s. They're essentially computers, right? So not computers in the sense in the sense that we're familiar with, but they were actually called computers, and it was a job, uh, and all they did was compute. Um, all right, so like this is before we had computers. They would hire people who would compute or calculate things. And as you may imagine, it didn't pay much. And that's because it was thought to be very mechanical. You could just follow some sort of algorithm. Anybody could do it as long as you just blindly followed the steps. So the traditional view of computation, anyways, that was an aside. But so the traditional view of computation is that information is encoded in propositions. It's encoded and stored as propositions. So in order to talk about this, I need to explain what a proposition is. So a proposition is simply a statement that relates concepts to each other. So a proposition is simply a statement that can be true or false. So for example, John likes cats. That is a proposition. John is a concept and cats is a concept, and likes is a relation that connects John to cats. Uh, and so again, a proposition isn't a sentence. It is sentence-like, but it's not necessarily a sentence. It's an assertion about the world that can be either true or false. So the book is red, the book's color is red, and el libro is rojo. These all express the same exact proposition. And complex sentences express more than one proposition. So, for example, the sentence, the big brown dog is hungry, there's actually three propositions embedded in that sentence. So, dog one is big, dog one is brown, and dog one is hungry. Okay, so those are propositions. And so information is encoded in propositions, and these propositions are combined into logical structures. And according to this view, thinking is simply the manipulation of propositions. So computation is just simply the manipulation of symbols according to rules, and you just simply need to follow these formal rules. And computation in this sense can be done in sort of a blind or mechanical way, which is very useful if you're trying to explain things in a simple mechanistic way, right? And so Alan Turing was a logician and mathematician from Britain. Some of you probably saw the movie Imitation Game starring Benedict Cumberbatch. And in that movie, and in the real world, he cracked the Nazis' Enigma machine in World War II, which was a device that encrypted messages among military officials. Not only did he shorten World War II and saved many lives in the process, but he's also considered to be the father of computer science, if not just very important to computer science. I believe he's the father, but I'm not, don't quote me on that. Um, and so, yeah, computers are integral to our lives, but they wouldn't have been possible without some key theoretical breakthroughs that he and others made in the field of mathematics and logic. And so, yeah, for the next slides, I'll talk more specifically about what he did by discussing the concept of computability. And so let's just stop here and I'll start again for the next video.